So in this lecture, we'll discuss some of the basic equipment that you're going to be using when you're building your Internet of Things devices. And some of the basic equipment that we'll be talking about through the class, we'll assume that you're using. Just to make things a little more concrete, so you see, I've been more generic earlier in the earlier lectures about what the general type of equipment, but now we'll actually point to the specific things that we were going to cover in this class. And then when you do the capstone, you'll be using this type of equipment when you do your capstone. So first, the main thing we're going to use is a development board of some kind. It's a board that has a microcontroller on it, okay? And which is, of course, the center of all these projects. The center of these systems is going to be some microcontroller with some code running on it. So the picture that we have here is actually an Arduino board, and that black chip on the board is actually the microcontroller itself. Now there's other hardware on the board. There are interfaces, like for instance, you can see a USB interface on the side. There are a bunch of holes on the side that you can't see yet, but those are plugs we're going to plug wires into. We'll do that later. There's power, and often there are other interfaces on the board. So there are other interfaces on the board. There are also other chips on the board and other devices on the board. So there's the microcontroller, but there are other things that are used on the board. Generally, those development boards, what they are, for the most part, the main thing they have to have is a microcontroller that you're going to program, but also hardware on the board to program the microcontroller. So basically, data has to get taken from the USB cable typically. So this has a USB port. It has to get taken from the USB cable, which is connected to your host. It has to get taken from the USB and programmed into the flash memory of the microcontroller when you want to put a program onto the microcontroller. So typically, these boards are minimally, they will have equipment on there, hardware on the board, whose job it is to read the USB cable and take the data that is received on there and program it onto the microcontroller. That's sort of a minimum thing that you're going to find on these development boards. Now then, a lot of different development boards have lots of different extra equipment in addition to that. Maybe you have compasses, accelerometer, magnetometer, all sorts of extra components you can find on these boards, touch-sensitive screens, all this stuff. But the basic board is just what I'm talking about right now. And the boards that we're using, certainly an Arduino is pretty basic. It has basically what I just said, and that's an Arduino right there. It has very little else besides the microcontroller, the hardware used to program the microcontroller, plus the interfaces, USB and the pins and stuff like that. That's basically all an Arduino has on it. Now we're also going to use a Raspberry Pi, and we'll go into that in more detail later. That has more things on it. That actually has an accelerometer on it. It has a magnetometer, meaning a compass. It has a few other things on it, but it's mostly pretty bare. It has a processor on it too, a microcontroller on it too. I would say it's a higher end microcontroller than what you find on Arduino. But that's the core of the system. So that's how we're going to start. We're going to take these development boards, plug them in by USB to our host, our laptop desktop, write code on the laptop desktop, program it onto the microcontroller on the development board. Now, other equipment you're going to get. USB cable, clearly, just to connect the board up. Ethernet cable is a common piece of equipment. I don't know if we'll be using that, but Ethernet is common because a lot of these boards have Ethernet cables, have Ethernet jacks, because we want them to be networked, right? We're talking about Internet of Things, so it's common to have an Ethernet jack. Raspberry Pi does, standard Arduino does not, but it's common to have Ethernet jacks, and then you would need an Ethernet cable to connect to that. Jumper wires, so you're going to need a set of wires. You'll get a set of wires to plug into the input pins of the board. So that Arduino that we saw in the last slide, it had several holes. You can plug wires into those holes to connect up other things. Different inputs. These are components that we will commonly use as input components. So essentially sensors. So a potentiometer. A potentiometer is a sensor that senses how much turn. It senses rotation. So if you turn something more, it turns to the left, turns to the right, it changes the resistance between two signals. And you can use that as a rotation sensor. So if you want to implement a volume knob or something like that, you can use a potentiometer and sense how much is turned. Photoresistor, so that's something that senses the brightness. So the brightness of the light will change the resistance on a certain resistor, and you can sense that. Keypad, that's another common component, just a bunch of buttons put together. Buttons, individual buttons, that's another common piece of equipment, and we'll have some of these. Some of the outputs, LEDs, so those are light emitting diodes. You've seen those little lights that turn off and on, light emitting diodes. Resistors, we'll talk about those later. They don't do much. They consume power and they change voltage for us, but simple components. We're also going to use a breadboard. Now breadboard, actually I have a picture of that on the next slide. So breadboards are for wiring. So we're going to have a bunch of these components and we're going to need to connect these components together. And so how do we connect them? Well, there are several ways. One way is to solder things, and we are not going to do that. Soldering is a more permanent connection, where you take two pieces of wire, two pieces of metal, you want to connect, you take an iron, a hot iron, touch it to the joint, you bring some solder, which is softer metal, you melt it onto the joint and it forms a seal and it connects them electrically. So that's soldering. We won't do soldering because soldering, well, several things, but the main thing is soldering is more permanent, and we're just prototyping, right? I mean, you're going to be trying things and trying things again, making mistakes, trying again. So soldering is too time-consuming. Soldering is more permanent. In the end, when you're done, you know everything works, then you might solder things together. But we're not in that mode. We're going to be using a breadboard. So breadboard is for permanent, non-permanent wiring. So basically, it's got a bunch of holes, a board with a bunch of holes. And these holes fit 24-gauge wire, which is the common wire size for components like this. And these holes are connected electrically. So there are rows of 5 holes you can see there. And if you put a wire into one of those, one hole in a row of 5, all the other rows of holes in the same row of 5 are connected. So you can plug 2 wires into 2 different holes on the same row of 5, and they are connected. And that's how you connect components. So you can plug one connection from a component into one hole in the row and plug another component into another hole in the same row, and then those 2 components are connected. Okay? So this is how we're going to be doing wiring. We're going to have our breadboard, and we connect things in that way. Now, if you look at the breadboard, it's got these rows of 5, but then along the left and right sides, you've got these columns, right? These 2 columns on the left, 2 columns on the right, with breaks in between, but basically 2 on the left, 2 on the right. So those columns are actually wired differently. They're not wired horizontally like those rows of 5. They're wired in columns. So there's 2 columns on the left. All holes in the same column are connected to each other. Then all holes in the next column are connected to each other. Same thing on the other side. All holes on the one column and all holes on the next are connected. So traditionally, those columns are used for power and ground. Because usually, when you make a system, you have a lot of chips and a lot of different components in there, and a lot of them need to receive power and need to be connected to ground. So it helps to distribute power and ground across the whole circuit, to just put power and ground into those rows, those columns rather. So put power into one column, ground into another. Then anything you want to connect to power and ground, you don't have to run a long wire, you just run a wire straight to that column, to the nearest hole on the column. So we'll be using breadboards to connect up our components. And it's very common for prototyping, and it's made at a specific size. It's a common size. Here's a typical circuit. This is just one possible circuit, but there's an Arduino. And this Arduino, it's connected to some LEDs. You can see those red LEDs that are in the breadboard, right? So the LEDs are plugged into holes in the breadboard. They have 2 leads. So an LED has 2 leads, 2 wires. They're connected to holes in the breadboard. There are also resistors. I don't know if you can see them, but those little components that connect from the LEDs to the bottom row, those are called resistors. And we'll talk about that circuitry. You always want to put an LED in series with a resistor. If you don't, then what will happen is you'll drive too much current through the LED and you'll blow it out and it'll burn out. It'll be very bright for a second, then you'll hear a pop and it'll be gone. So you put resistors in there just to slow down the current, basically to reduce the current. Not slow it down, but to reduce the amount of current that goes through. And the other side of the LEDs are connected by those blue wires into the Arduino. And the Arduino has some program running on it that probably turns on the LEDs, turns them off and on in a particular sequence or whatever you want it to do. So those are the type of components that you will be using in the class and we'll be talking about in the class. Thank you.